Hi, this is a granulation of powders experiment, data analysis and calculations. Our experiment objectives were to investigate several different factors that may affect the properties of granules when prepared using wet process, massing and screening as an example. But while our main objective was to determine best binder, this will be done based on prepared granules macroscopical properties and most efficient binder based on the calculated percent yield per unit mass of the binder. How to do so? First, best binder, which is the most important thing to determine in this experiment. As we said, this will be determined based on macroscopical properties of our granules. These macroscopical properties include particle size distribution, particles shape, uniformity of particle size, shape, percentage of fine particles in the final granules, and color changes. Based on this, granules with the largest particle size, narrow particle size distribution, spherical shape, uniform shape, least percentages of fine particles, and no color changes unless a coloring agent is used, are the best granules or are prepared using the best binder. The most efficient binder will be determined based on the percent yield per unit mass of the binder. The highest percent yield per unit mass of the binder indicates the highest efficiency. How to calculate the percent yield per unit mass? First, you have to arrange your data in similar table to this we are showing you. The first step to calculate the percent yield per unit mass is via calculating the binder weight, and this will differ based on the binder. For water, the binder weight is equal to the endpoint, the volume used from water, times the density of water. While for sucrose, this will depend on the concentration of the sucrose solution we prepared. As you can remember, each 100 ml of the sucrose solution contains 50 grams of sucrose. Then, the amount of sucrose used will be equal to the endpoint times 100 divided by 50. The same case is with starch as a binder. The weight will depend on the concentration of the starch mucilage we did prepare. Remember, each 100 ml of the mucilage contains 7.5 grams of starch. Now, the theoretical weight, which is equal to amount of powder we used in addition to binder weight. Remember, each time we did granulate 400 grams of lactose. Theoretical weight usually represent the summation of all ingredients weights assuming no loss. Now, the practical weight. The practical weight is equal to the actual weight, the dried granules weight, the completely dried granules weight, which is equal in numbers to dry weight minus tray weight. You should keep in mind that the dry weight we measured is equal to the tray weight and the granules, the completely dried granules weight, while we need to calculate the practical weight, which is the completely dried granules weight or the actual weight. And here is the percent yield. Percent yield is equal to practical weight divided by the theoretical weight times 100%. And finally, percent yield per unit mass of the binder will be equal to percent yield divided by the binder weight in grams. Again, keep in mind that the unit mass of the binder we are using is 1 gram. Now, build up your portfolio pages. As we said during the practical sessions, you can use a preset template on a Word document as can be shown. Please prepare this page with the specified layout and keep it to be used for this experiment and all of the upcoming experiments. This may take a couple of minutes to prepare it. Now, just copy and paste Excel tables and charts. Always start with results tables, then calculations and data analysis. Here are some questions for you to answer. Based on what wet granules drying conditions are selected? How would incomplete drying affect the calculated percent yield? Remember, this will contribute toward the estimated practical weight to be higher than expected. Then, the percent yield will be higher than expected. How would not achieving the granulation endpoint affect the granules properties? This means if we didn't continue addition up to the end point. This will affect the granules properties, ending with friable granules or weak granules, as well as will affect the calculated percentage yield in different ways. How would exceeding the granulation endpoint affect the granules properties? Again, this will affect the granules properties via ending with relatively hard granules relative to the ideal hardness related to the correct endpoint, and this will cause the calculated theoretical weight to be higher than expected. Granules should be distributed as uniform thin sheet on the tray to assure uniform drying. Also, drying stage can be problematic as convection currents may affect the ingredients distribution. Please make sure to know this effect. Describe dry granulation method and for what type of powders it should be used. Remember, in wet granulation, the properties of final granules is determined by both quantity and rate of application of the granulating liquid. Thank you all.